today I want to look at some weird examples here. So we have some equations that look like polynomial equations, but they're not polynomial equations because they have fraction exponents. And factoring fraction exponents sounds really weird. What do we do? Alright, so let me show you. So for part A here, we have y to the 7/2 power minus 5y to the 5/2 power plus 6y to the 3/2 power equals 0. Now the technique that you want to apply to equations that look like this with fraction exponents is that you want to factor out the term of the lowest exponent. Okay, so every time you take out the variable with the lowest exponent. Okay, so let me show you what I mean. So for part A here, I look at my exponents. I have 7/2, 5/2, and 3/2. 3/2 is the smallest. Okay, so that means that the other two contain 3/2 in them. So I can factor out a y to the 3/2 power. Now remember, when you do that, so like if I had, for example, let's think for a moment, if I had an x cubed minus x squared plus x, and I factored out an x, what do? I subtract, that was a degree 1, I subtract out the 1 from everything else, okay, from the powers. So here when I take out y to 3/2, I'm going to subtract that exponent from everything else. So that means I have a y to the 7/2 minus 3/2 is 4/2. And then I have a 5y to the 5/2 minus 3/2 is the 2/2. And then 6y to the 3/2 minus 3/2 is y to the 0, which is 1, and that's equal to 0. Okay, so now I have y to the 3/2 power times y squared minus 5y plus 6 equals 0. That looks a whole lot better. And we can take this on pretty quickly. Y to the 3/2 equals 0. You raise each side of this to the 2/3 power. So that becomes y equals 0 to the 2/3 power is 0. So there's your first one. The second one is just a simple quadratic equation. So I just need to think of two things and multiply to give me 6 and add to give me -5. How about -3 and -2? So that gives me a y equals 3 and y equals 2. So there are my three solutions. Now the funny thing is that this equation had fraction exponents, but it has only integer solutions. Okay, so that may be surprising. Alright, now let's look at part B. The technique's the same, except now we have a negative exponent, so it makes it look a little bit more confusing. Okay, so this time I'm going to take out 2x minus 5 raised to the smallest power possible here, which is -2/3. When I do that, we have to be careful. What did I do over on this side? When I took out the 3/2, I subtracted 3/2 from the 7/2. So this time I'm subtracting -2/3 from 1/3. So 1/3 minus a -2/3 becomes 2x minus 5 to the 3/3, right? 1/3 minus a -2/3 becomes 3/3. On the other side, I took out all this, so I have just a -3 equals 0. Okay, so that means, simplifying it, I have 2x minus 5 to the -2/3 power times 2x minus 5 to the 1 power minus 3. Okay, so that's going to give me an 8 there. Okay, so now on this first side, this is the tricky part. I have 2x minus 5 to the -2/3 power equals 0. Alright, you have to remember that the negative is a reciprocal. So this means 1 over 2x minus 5 to the 2/3 power equals 0. Okay, so they have a 1 in the numerator and something in the denominator. For what value of x is that thing going to equal 0? It never will, because there's no variable in the numerator, so the numerator can never be 0. And if the denominator is 0, that makes this thing undefined. Alright, so there's no value of x that will make this 0. Okay, so we have no solution from this portion. Okay, this does not give us a solution. Now, on the other side, I end up with 2x minus 8 equals 0. This will give us a solution. 2x equals 4, so that means x equals 2. And there is my one solution to this equation. Okay, so this technique, even though it looks a little weird, works the same way as typical factor by grouping. Okay, you always pull out the variable to the lowest exponent possible. If you have any questions on this, or if you have some homework questions that you don't understand, I'd be glad to help you go over them. Just let me know, and thank you for watching.